Hello guys, we are now discussing the next topic, conjugate of a matrix. So what is a conjugate basically? When we take a complex number is that is we can take a is equal to x plus I y. So conjugate is basically the negative value of imaginary point. तो here जैसे कि हम देख रहे हैं यहाँ पे जो मेरा इमेजिनरी पॉइंट है ये है इमेजिनरी पार्ट, इसको बोलते हैं इमेजिनरी पार्ट. दिस इज द इमेजिनरी पार्ट आई वाई एंड दिस इज द रियल पार्ट ऑफ अ कॉम्प्लेक्स नंबर. सो conjugate is basically the negative value of imaginary part. So if a is equal to x plus iy, then we can denote the conjugate of a matrix is such that a dash a bar ऊपर में. So a bar is equal to x minus iy and this is called the conjugate of a matrix. We can take another example जैसे 1 plus root 2 I. Here root 2 I is the imaginary part. So we can how we find the conjugate? We can do that 1 minus root 2 I is the conjugate of a matrix or complex number. So this is the concept of conjugate of a matrix. Or so we can take a example of a matrix that is 1 plus I 0 0 and 1. So I'm here to understood you that how can we take the conjugate of a matrix. So this is the matrix. We can take the conjugate of this matrix, which is denoted by a bar or a dot बोल सकते हैं इसको. So this is 1 minus I 0 0 and 1. So this is the concept of conjugate of a matrix. We have to take a matrix, then the complex number that is the elements of the matrix. We have to do that. We have to take the conjugate of the elements of the matrix, which is a complex number. So my next topic is Hermetion matrix. Hermetion matrix, what is it? I will let you know that when we take the conjugate of a matrix and the transpose of this conjugate is called the Hermetion matrix. So we have to take a matrix like we have already taken a matrix that is a is equal to 1 plus I 0 0 and 1. This is the matrix that we have already taken here. We can see that. So we have to take the conjugate of this matrix, which is denoted by a bar, which is equal to 1 minus I 0 0 and 1. Then we will see that we can find the conjugate of this matrix when we do the conjugates bar, which is conjugates transpose. We can find this 1 minus I 0 0 and 1, and this is also the. Here we will see that the value of a conjugate is equals to a conjugates bar or transpose, that is also equals to that is not also equals to. Here we will find that the conjugate and the transpose are equal. Okay, so this is called Hermetion matrix. When we take the transpose of a conjugate of a matrix, that is called the Hermetion matrix. This is the concept. So Hermetion matrix are also two types. One is Hermetion and another is skew Hermetion matrix. Okay, one is Hermetion and another is skew Hermetion. Okay, so I will let you know that what is skew Hermetion matrix. when we transpose a matrix, when we take a matrix, after doing the conjugate of this matrix, we can take the transpose of this matrix, and this is equals to minus a, and this property holds if a matrix is skew Hermitian. So first of all, here we will see that we have to take a matrix A and do the conjugate of this matrix. We can, after finding the conjugate of this matrix, we'll have to transpose of this matrix. If the transpose of this matrix, you will see that we can find the transpose of this matrix after finding the conjugate conjugates transpose of this matrix. If the value of conjugates transpose is equals to equals to minus a, then we will tell this as a skew Hermitian matrix. So I have to tell you the some important points, which is nilpotent matrix. Nilpotent matrix. What is it? Nilpotent, nil means zero. When we take a square is equals to 0, means we have to take a matrix A and multiply with the same matrix A. If the value of this matrix is 0, then we call it a nilpotent matrix. But in this situation, we will have to know that no one matrix can be 0. Just for example, some student thinks that if the value of a will be 0, then we can find the value of 0. But we don't have to take the value of 0, because a is a matrix, not a number. So we have to multiply like 1 2 3 4 and 1 2 3 4. When we multiply these two matrices, if the value of this 0, then we call it nilpotent matrix. So I have to tell you some more other points, which is a square is equal to 1. This is called idempotent matrix. Idempotent matrix. What is that? When we multiply a into a to matrix A, if we find a identity matrix, then this is called idempotent matrix. If this property holds, then the matrix is called that idempotent matrix. We have another point, that is AB equals to 0. Here A is a matrix and B is another matrix. Okay, so if you should take that A is equal to 0 or B is equal to 0, you can't take it, because A is a matrix, A is not a number. Here you have to multiply A cross B, then you will find 0. Here a special condition satisfied, that is neither A nor B is equals to 0. You have to take it that neither A nor B is equals to 0. Then we can I can also have to tell the properties of a transpose of a matrix. Properties of a transpose of a matrix. This is just small one. Yeah, you can take this, you can learn this in this video. Okay, so A is a matrix, we can take A is a matrix. Then if we find the transpose and also doing the second transpose, if we find the same matrix. If we 2 times taking the transpose of a matrix, we will find the same matrix. This is the property 1. Property 2 is A plus B transpose. That is also called De Morgan's law or theorem. So here we will find that A plus B is transpose is equal to A transpose plus B transpose. And the third one is A B transpose. That is also a these two theorems are from De Morgan's theorem. De Morgan's theorem. Okay, so when you multiply A into B, two matrices, and in taking the transpose of them, you will find that B transpose into A transpose, that is individually you have to do the transpose of B and A, then multiply B into A, then you will find the, then you will satisfy the conditions. Okay, so the fourth point is, you can write a matrix as a form of symmetric, as a summation of symmetric and symmetric, that is A is equals to half of A plus A dash, which is A transpose, plus half of A minus A transpose. This is a this is, we can take a matrix A, we can write it as sum of symmetric and symmetric, where you can see that A plus A transpose and A minus A transpose. If we are breaking this equation, we will find half of A plus A transpose upon 2 plus half of A plus, sorry, minus A transpose upon 2. Here A transpose upon 2 plus and A plus minus are cancelled out, and we will find A by 2 plus A by 2, which is also equals to A. So here this is the symmetric and this is the symmetric. Okay, sum of symmetric and symmetric matrix. We can, matlab, in this fourth point we will learn to know that a matrix can be written in the form of summation of symmetric and symmetric. In another video I will taught you the multiplication of matrices and block multiplication of matrices. Thank you.